let us discuss about concept of differentiability of a function. So we know that a function is derived and differentiated, is differentiated, and it is the property of a function. Now, when a function is differentiable, so it is differentiable at a point if it has a well-defined derivative at that point. So if derivation can be done at a particular point, so the function is, or function is said to be differentiable. So meaning is that it has a tangent line at that point. So when you say dy by dx, suppose q is the function of x and y, and dq by dx or dq by dy, so it is the tangent line at that point. So to be differentiable, continuity is necessary for a function. So first thing is that the necessary condition of differentiability is that the function should be continuous. But it is not a sufficient condition. So it is not that it is continuous, so it can be differentiable, but sometimes it is seen that even if it is continuous, it is not differentiable. So there should be three important conditions of differentiability. So they are continuity, so there should not be any break or jumps. The function should be continuous. No sharp corners or curves creating multiple tangents. There should not be sharp corners. Then no vertical tangent exists. And differentiability means that for the given initial value, suppose x is equal to x naught, so x naught is the initial value of in the domain of x and y. So x naught is the initial value. The difference quotient, if y is the function of x, then difference quotient is change in y by change in x. So in the domain we have the values of y and values of x. Suppose y has changed from one point to other, from one observation to other observation. So there will be change, how much it has changed. Then similarly for x, suppose height and weight of a person. Now, if height we have, suppose height is x, we have recorded this much centimeter and this much centimeter. We have against that we have recorded weight, this much weight. If height is this much, weight is this much. Then if height is this much, weight is this much, like that. So when we find out the change of height and change of weight, that means here weight is dependent on height, so that's why y will be weight and x will be height, suppose. So change in y by change in x is equal to fx naught plus delta x minus fx naught divided by delta x. So it has a limit as delta x tends to 0. So suppose delta x, that means change in x is very, very small, very, very small. So in that case, delta y by delta x may not exist. It will be very, very small. The function is continuous. So it is said that in this case, the function is continuous. all differentiable functions are continuous. So it is the common remark that all differentiable functions are continuous. Without proof, sum, difference, product, and quotients of any finite numbers of continuous functions are continuous. So even if we do not go for examining whether it is continuous or not, so if it is the sum or then difference or product or quotient, the functions are in this form, then any finite quotients of any finite numbers, then the function will be continuous. First is to say continuity of the function and then derivative of this. If well-defined derivative exists, suppose it is sum or difference, product or quotient. Now we have derived. Now if derivation exists, then and it is finite also, then the function is finite at that point. Then continuity of a function can also be said at a point. It is continuous if the derivative at left hand side equals the derivative at right hand side. So if we derive at the left hand side and right hand side of the function, then we see that if the derivatives are equal, then the function is continuous and it is differentiable. Now certain diagrammatic or schematic diagrams are there. When a function is differentiable and when it is not differentiable. So the schematic, suppose diagram A or figure A, the function is continuous. You see, the function is continuous, no break, nothing. So it is differentiable. So the function can be differentiated. If algebraically we put this function, then we find that it can be derived. dy by dx, we can do that. And break. Now B to Z, so this is B, C, D, E, F, G. So B to Z diagrams, they are non-differentiable. So you see there is break. So this function, there is break, then again it has started. There is break. Then the jump. You see function, it has started from here up to this. Then after that it has jump. So this is the gap, it has created the gap. So this is also not differentiable. Then infinite. You see the function has gone up. So there is no destination. That means there is the infinite. It is infinite. It cannot be differentiated. Then it has corner point. You see, it has corner point. So if a function has corner point, then also it cannot be differentiated. Then it is called curves. You see, it has, the function has started from here, touches 0 point, then it has again increased, like that. So in such kind of function has no differentiation. It cannot be differentiated. So the algebraic form may be of this type: 2 times x minus 1 to the power 2 by 3 at x is equal to 1. And in case of corner, so cos inverse is a cos x. Okay. So Next is this, fx is equal to cubic root of ax. If the function is of this type, then it is not differentiable. So this is up to z. So from a to z, only a function is of this form. It is differentiable, others are not differentiable. So with this, I thank you for listening on concept of differentiability of a function. We'll discuss different types of functions in our next discussions. Thank you for observing. Thank you.